All right, so let's talk about horizontal and vertical asymptotes. So let's start with vertical asymptotes. They're going to have the equation x equals some number, so we're just going to say a. The graph behavior will approach the vertical line and either increase or decrease without bond. So here's some notation here, guys. So it says the limit as x approaches a, and do you see that little negative sign there? That little negative sign means from the left. Because your negative numbers are on the left, okay? So it's just saying it's coming from the left side towards that x value of a, wherever it's at. And we know it said that the graph will either increase or decrease without bond. So my f of x is going to equal, it'll either be positive or negative infinity, depending on the graph. Then, over here it says the limit as x approaches a, and you see it has a little plus sign there? Which side of your positive numbers are on your graph? So this is from the right. Of f of x equals, and again, it's going to increase or decrease without bound, so it's either going to go towards positive or negative infinity. So let's practice one. Let's look at the graph they gave us over there on the right. Do you see where your graph is going up and down and how it looks like there's a line there in between it?
No, where? Okay.
Right here where I'm drawing in. That's going to be our vertical asymptote. Where is it at? At x equals -3. So if I was going to write this out using this notation, we would say the limit as x approaches -3, and we're going to look at it from the left, so put a little negative sign up there in what you would think of as the exponent area. Okay, that just tells me we're only looking at it coming from the left side of our graph. F of x will equal, and so actually look at that graph. I'm going to pick somewhere way over here on the left. Do you see my line that I just drew there? Now I'm going to make it blend into that other line they've got, so I'm drawing. Still drawing. What's happening to these y values? Where are they going to? Positive infinity. They're increasing to positive infinity. Or we could say, because it has to both be true now, so the limit as x is approaching that -3, and put a little plus on there, because now we're going to look at it from the right of our function. So f of x equals, now I'm going to come over here on the right side, and I'm going to draw my lines. So I'm graphing and graphing. And look what's happening to your y values. They're decreasing, so they're going to negative. And since both of these graphs are going towards the same x value, one from the left and one from the right, and one's going to positive and one's going to negative infinity, that tells us there definitely is a vertical asymptote at that line, x equals -3. All right, so let's talk about horizontal asymptotes. They're going to be in the equation of y equals some number, so we're just going to say b. The graph will tend towards positive or negative infinity along the line. It is possible to cross a horizontal asymptote. So, when we're dealing with horizontal asymptotes, remember we talked about this before, we're dealing with that end behavior. What's happening on the far left of my graph and what's happening on the far right of my graph. Okay? So they can cross in the middle somewhere there. But it won't happen as you're going out to the very ends of your graph. And so you can see here it says the limit as x approaches negative infinity. Well, let's just use this graph here. So let me erase my lines I had for the other problem. So look at this graph here. As x is going towards negative infinity, so that's this part, isn't it? What does it look like my y values are approaching? Negative. Well, yeah, be careful, because right here, there looks like there's a line that it's not going to touch on either end, isn't there?
1.
Yeah, so this line is at y equals 1, And it's going to be my horizontal asymptote because I can tell we're going out towards the ends. They're getting close, but they're flattening out. They're not going to touch it. And so by the definition then, as x is going towards negative infinity, we can see here that it's going towards positive 1. And as x is going towards positive infinity, so I'm going to come on this part of my graph, as my x's are going to the right there towards positive infinity, where does it appear my graph is approaching, my y value? It's also 1. Therefore, that tells us that we do have a horizontal asymptote at that y equals 1. All right, so with horizontal asymptotes, guys, there's 3 different things it can be. And so they have 3 different cases here. It says, if the numerator degree is less than the denominator degree, then the line y equals 0 is a horizontal asymptote. And so an example of that would be like if I had y equals x minus 2 over x squared minus 6x plus 10. Now, how do you find the degree of the numerator? Do you remember? It's the largest exponent. So the degree of the numerator is 1. The degree of the denominator here is what?
2.
And because the bigger one's on bottom, it's going to be y equals 0. The second case says, is the ratio of the leading coefficients is a horizontal asymptote. I'm sorry, I forgot to read the first part. Then if the numerator's degree is equal to the denominator's degree, then the ratio of the leading coefficients is a horizontal asymptote. That means that y is going to be equal to a over b. So what that's saying is if we have this equation, like y equals 5 minus 8x squared over 2x squared plus 3x minus 4, we can see the degree of the numerator is going to be what? What's the degree of the numerator? 2. What's the degree of the denominator? 2. And because of the same degree, then we're going to take the ratio of their coefficients. So you're going to take the negative 8 over the 2. And what is negative 8 over 2?
4.
Yeah, so y equals negative 4 would be your horizontal asymptote for this one. And then the last case they have is if the numerator of the numerator degree is greater than the denominator degree, then the graph has no horizontal asymptote. So if I take like if I have y equals x squared minus 5x plus 4 over x minus 2, my highest degree is in the numerator. Therefore, there's not going to be a horizontal asymptote. Now, you can memorize that if you want to. But I use a little shortcut when I'm dealing with horizontal asymptotes, and it's no. I'm just going to kind of put it right here in the middle in a think bubble. Everybody see where I'm at?
Oh, yeah.
All right, so I use no. If it's on top, your highest degree now, your largest exponent, if it's on top, it's none. You don't have one. If it's on bottom, it's y equals 0. Or if it's both, you're just going to have to know it's the ratio of those leading coefficients, okay? So top is none, bottom is y equals 0, and both is the ratio of their coefficients. Instead of trying to remember if it's greater on, or if it's smaller on bottom, it's 0, it's no. That helps you remember top and bottom. And then you have to just know a over b if it's the same.